All right, 6.2 is all about taking the integrals, the antiderivatives of exponential and trig functions. At the top of the lesson, you've got a lot of different functions listed here. Most of these are just going to be look at the formula, find which one, or look at the problem, find which one up here it connects to. These aren't all formulas that I think are necessary for you to remember, but there are a few that come up a lot. E to the x is going to come up a lot. The integral of e to the x is just e to the x because remember the derivative was itself. The a to the x one, I don't think there's any reason to memorize that one. We just really don't see it come up very often, although it is in one of the examples below, so I included it here. Cosine is an important one because when you go backwards, when you take the integral of cosine, you get positive sine. Remember, the sign changes when you take the derivative of cosine, but we're going backwards. And so it's kind of like we're undoing the derivative of sine, so the sign stays the same. But the next one, when you integrate sine and go backwards, you get negative cosine. So going forwards, when you take the derivative of cosine, you get a sign change. Going backwards, when you take the integral of sine, you get a sign change. So just be careful. That's by far the most common mistake on these kinds of questions on the AP test. There are a few other trig ones here. I wouldn't worry too much about memorizing them, especially at this point. But you'll want to be able to refer up to these and recognize them and how they connect to the problems below. So if you see secant squared, then come up here, find the formula. If you integrate secant squared, you get tangent. If you integrate cosecant, you get negative cotangent. The secant tangent gives you secant. Cosecant cotangent gives you negative cosecant. So the three to memorize are definitely those three that I starred for you. The rest of them would be great to know, but definitely aren't something you're going to see a lot. So examples. Number one, find the following antiderivatives. So I want to integrate negative 3 sine of x. I can put that negative 3 in front. So all I'm integrating is sine of x dx. And if I look up above, the integral of sine is negative cosine. So this becomes negative 3 times negative cosine of x plus c. Negative 3 times negative cosine is just positive 3 cosine of x plus some constant c. You don't have to pull that negative 3 out. You could have left it in and just recognize that the sign is going to become negative cosine, which is going to take the negative 3, make it a positive 3. So yeah, you don't have to factor out that constant in front. Anyway, number two, integral of e to the x minus 2x, 2 to the x dx. So this one we can split up into two different integrals. So e to the x, when I integrate, is just e to the x. Negative 2 to the x, I'm looking up here at this one. It says that I put the 2 to the x on top, and then on bottom of the fraction, I put natural log of whatever the base is, which is 2, and then I get my plus c. Okay, number 3, I can't integrate with the root there and all that mess, so I'm going to rewrite number 3 first. I don't like what it just did to my integral. So integral of, instead of 5 cube root t squared, I'm going to rewrite that as 5 times t to the 2/3 plus 3 cosine t minus 1 dt. Okay, so integrate these individually. t to the 2/3, I've got to add 1, which is going to become t to the 5/3, which means now I have to divide by 5/3, which is the same thing as timesing by 3/5. So I've got 3/5 multiplied by 5 out in front. Cosine of t, up above it says cosine just becomes sine. So that just becomes 3 sine of t. -1 from last lesson, you learned that becomes negative t plus c. So when I clean this up, those 5s are going to cancel. So I get 3t to the 5/3 plus 3 sine of t minus t plus c. If you are unsure, take the derivative and see if you end up back where you started, right? You can check your work that way. All right, number 4, I've got a fraction. I don't like that divide by 4. I'm going to make that a 1/4 and put it in front because I don't want to deal with it till the end. So the integral of secant y tangent y dy. So when I look up here, I'm looking for secant tangent, which is right here. And it says the integral of secant tangent is just secant. So I end up with 1/4 secant of y plus c. So just 1/4 secant y plus c. All right, number 5. If f prime of x is cosecant x squared and f of 5/4 is 3, find f of x. So I'm going to take, I'm going backwards. I have the derivative. I want the original f of x function. So I need to integrate this function. So f of x equals, now the integral of cosecant squared, I believe is one of these up here. Cosecant squared is negative cotangent of x. So I get negative cotangent of x plus c. Now I want to plug in, it gives me an initial condition so I can solve for c. So I'm going to put a 3 over here, and that equals negative cotangent of 5/4 plus c. Now cotangent is cosine over sine. So this is the same thing as 3 equals negative cosine of 5/4 divided by sine of 5/4 plus c. If I look at my unit circle, 5/4, sine and cosine are negative root 2 over 2. So 3 equals negative root 2 over 2 divided by negative root 2 over 2 plus c. Well, negative root 2 over 2 divided by negative root 2 over 2 is just 1. So this just becomes 3 equals negative 1 plus c, which means that c is equal to 4. So now I can plug that value in here for my f of x. So f of x equals negative cotangent of x plus 4. All right, homework. Again, the focus is the new stuff. You need to do the review problems, but before next class, make sure you at least get the new stuff done so that you're ready for the homework quiz. And then we can focus on answering questions for those other ones after if you need to. And then next time we'll start working on 6.3. So come see me if you have any questions.